Hello, and welcome back. Over the next several videos, I'm going to dig into time-lapse and hyperlapse from photography, from concept and setup, to camera settings and shooting, and finally to post-production and processing. But in this video, we're going to start at the beginning and look at what a time-lapse is and the concepts and considerations that go into a time-lapse shot. Now, if you're new to time-lapse photography, let's start at the very, very beginning. What is a time-lapse anyway? And what are hyperlapses? You may have heard the term and wondered if it was related, and if so, what they were and what makes them different. Well, put simply, a time-lapse or time-lapse photography, though ultimately we do end up with a video, not a photo, is a process where you speed up the natural progression of time by shooting at a much lower frame rate than the content will ultimately be played back at. So where we typically shoot and play back video at 24, 30, or 60 frames per second, in a time lapse, we're going to shoot the video at frame rates that are more like 1 frame per second, or even several seconds or minutes per frame. Of course, we still play these back at those normal frame rates, and as a result, what took minutes or hours to shoot takes seconds or minutes to play back. So then you might ask, what is a hyperlapse? Well, put simply, it's just a time-lapse with a camera movement. So that camera movement could be a pan, a tilt, a dolly, a zoom, or even something like walking down a street or flying a drone over a landscape. Put another way, all hyperlapses are time-lapses, but not all time-lapses are hyperlapses. The difference is that camera movement. Now, when it comes to shooting video, camera motion is often an incredibly useful tool at adding interest in your scenes. And the good news here is that if you want to do this with time lapses, making them into hyperlapses, they are more accessible than ever before thanks to the decreasing costs of motion control and stabilization hardware and increases in compute performance and capabilities. So that's the what a time-lapse is. But the next question you might be asking is, why bother? Why not just shoot at a regular frame rate, and if I need to speed it up in post? After all, if you've done anything with video, you might have realized that you can speed up any video content without compromising image quality. You simply skip frames. So why not shoot everything at your regular frame rates, and then if there's something creatively interesting that you need a time-lapse for, just crank the speed up? Well, to put it simply, you absolutely can do that. In fact, you might need to do that if you want to speed ramp down to real time in your footage. Now, the problem here, and this has always been the case, is storage. Whether you're shooting on film or digital, motion pictures create a ton of information that you have to deal with. Now, the costs and the exact way that information is handled are certainly different, but it is the same problem nonetheless. And when we're talking about video or digital video, we go to great lengths to save space everywhere we can to make the file sizes reasonable. You've probably heard of things like chroma subsampling, log curves, compression algorithms like HEVC and AV1, or even ProRes for that matter. You've probably heard of raw video. All of these, one way or another, are examples of trying to save space while still producing a motion picture image that is either the best possible quality or a quality that is good enough that people won't notice any problems. Now, of course, if you shoot at a very low frame rate, it becomes a super easy way to save space if the end goal is to speed up the playback of time. I mean, after all, if you think about it, every frame that you don't shoot and therefore don't have to save is data that doesn't need to be stored. Now, while that answers the technical side of why a time-lapse is shot, it doesn't really address the creative side of the same question. What function can or does a time-lapse serve in a creative endeavor? Now, for me, there are two ways to approach this thought process or thinking about time-lapses. One way is from the background of a photographer. This is kind of where I came into this originally, and in this case, time lapses are often really just an extension of a single image. So you take a single image of something like a sunset or a storm over a landscape or the night's stars progression in the night sky, and instead of just making that a single frame that you're going to share with people, you extend that in time by shooting a sequence of images and make it a time lapse. So stop or frozen motion becomes accelerated motion. Now, the other approach to thinking about time-lapse photography comes from cinematography. This is where a time-lapse is intended to be integrated into a larger story or production and therefore has to serve a function other than just being a moving version of a static picture. Now, in these cases, time-lapses tend to serve one of two functions. For dramatic works, at least this is usually going to be the case there, a time lapse is used to convey the passage of time and to potentially provide some distortion to the way the viewer perceives time progressing in the story. So an example of where you might see this is something like a character walks out of a scene, a time lapse progresses showing the transition of a day or many days, and then they walk into the next scene. This very clearly demonstrates how much time has passed between those two scenes instead of relying on the audience to, or implying to the audience that some time had passed. Now, the other use you will typically see from the cinematic or storytelling perspective is a bit more, we could call it scientific. That is, time lapses are often used to accelerate or show an accelerated version of a slow process at a speed where we as humans can understand what's going on in the time scales that we generally perceive things happening at. So this is frequently used in things like nature documentaries as to show the things like the growth of plants, the decomposition of things, or the creation or erosion of land through geologic processes. All of these are very slow, and if they tried to just show them as a factor of just normal time, you wouldn't actually see a difference to be able to convey what was going on. Now, of course, any creative work or decision being made in a creative work has to be considered in the larger context of what you're working towards for that project as a whole. What you want to do, or even need to do, if you're shooting a standalone time-lapse as basically a upgraded version of a still image, is going to be different from what you need to consider and do if you are using time-lapses in the context of a dramatic storytelling effort. However, in the end, we are still just talking about video, even if that process is heavily distorted in the way we're recording time. And that means that we have to think about what we're doing in those terms, in the context of video. Now, while many things are going to be the same between time-lapse and regular video or even photography, for example, composition, the acceleration of time is going to affect other processes much more. Now, for me, the biggest considerations that I've found that require extra thought when talking about time lapses are frame rate, how exposure and lights in the scene react, exposure times and motion blur, and camera movement. None of these are going to work quite the same or be implemented in quite the same way as they would be if you were talking about just shooting regular video. So let's start with motion blur. Fundamentally, as we said, we're shooting video, and it will ultimately be played back at normal frame rates. This means that we have to consider motion blur, especially if we are talking about frame rates at 24, 25, or 30 frames per second. Though, quite honestly, even at 60 frames per second, motion blur, while its need is reduced for providing a smooth-looking footage, it's definitely still something that should be there to a slight degree. Now, normally when we shoot video, we shoot it with a 180-degree shutter angle. In other words, we shoot with an exposure time that's 1/2 of the frame time, or in the case of a time-lapse would be the interval time. Now, for normal video, this would mean something like shooting with a 1/48 of a second shutter speed for 24 frame per second content. However, in our case with time lapses, if we're talking about, say, a 1 second interval time, we'd technically need to shoot with a 1/2 second exposure time to end up with the right motion blur in playback. However, shooting with these long shutter speeds isn't always practical. I mean, think about what would happen if the interval time was a minute and you needed 30 seconds for every frame. Even at night, sometimes this isn't going to be possible, and during the day, it's really going to be problematic, even with a lot of neutral density. Now that said, since a time-lapse isn't standard video, you can generally get away with not following the standard 180-degree shutter angle rule. In many cases, time-lapse clips will look fine, even if they're sharper than they should be due to a much shorter than normal shutter speed or exposure time. And in my experience, there really isn't a hard and fast rule for this. It kind of depends on the exact scene, the exact way it's being used, and so on and so forth. So you'll have to, if you want to try and do everything in camera, you'll definitely have to experiment and build up some intuition about what shutter speeds you need to use. Now, you could also do what I do, which is just fix it in post. Motion blur is one of the things that can be easily added in post with good quality, and doing it this way is just more flexible. You can shoot at shutter speeds that are dictated by the scene, the depth of field you want, the gear you have, and all of that stuff. And if the time-lapse looks wrong or looks stuttery in post or in the final video, add motion blur and correct it in post. So on this, we will be looking at several approaches to adding motion blur when we get to the post-processing section of this series of videos, so it'll be a future video. Now, the next consideration for me is frame rate. Or if you are looking for the setting in your camera for a time-lapse, it's going to be called interval time in many cases. Now, since I don't worry about getting the motion blur right in camera, knowing the frame rate I'm shooting at isn't an issue in terms of figuring out the shutter speed I need to work at. It solely exists to control how much time is sped up in playback and ultimately the quality of the time-lapse if I have to adjust its speed. Now, fundamentally, what we are balancing here is storage space that we save by not taking 24 or more frames a second, with the flexibility to adjust the time-lapse's speed in post. Now remember, if we overshoot, that is, we set a time interval that is shorter than what we really need and our playback is slower than what we actually wanted, we can always speed that time-lapse up in post without quality suffering. However, if we undershoot, that is, we set the time interval too wide, then we need to slow down the time-lapse in post because it's running too fast. Then we have problems, and we're either at the mercy of running our playback frame rate at a slower than anticipated frame rate, so maybe 30 frames per second instead of 60 frames per second, which might be okay, but what would not be okay would be like 12 frames per second instead of 24 frames per second. Or depending on generative frame creation algorithms like Ultra Smooth that's found in Topaz Labs Video AI, or Optical Flow found in DaVinci Resolve or Premiere Pro. Now, for me personally, I tend to always err on the side of overshooting my time lapses. I will often shoot at intervals of a half or 1 second for the kind of landscape scale scenes that I'm shooting that I intend to play back at, say, 24 frames per second. And this is even though oftentimes I will end up speeding that time lapse up in post, but if I don't want the extra speed, I have a slower thing to work with to start with. Now, if I was targeting 60 frame per second playback, I would almost certainly be having that interval time to say a half or a quarter second or 2 to 4 frames per second. Now that said, you don't have to guess at this. You can figure out both the frame count you need and the interval time that you have to set your camera up to with a little bit of math. However, to do this, you need to know the real-time process, or how long the real-time process takes and how long you want the time-lapse to run. Then you can simply figure out the interval by first multiplying the playback time in seconds by the playback frame rate in frames per second. That'll tell you the total number of frames that you need to shoot, and then you can divide the real-world recording time by the number of frames to get the interval time that you have to program your camera to use. So for example, if I know I want a time lapse to be 2 minutes long and play back at 24 frames a second, then I know I need 120 seconds of time lapse, that's 2 minutes in seconds, times 24 frames per second for the footage playback speed, which tells me I need 2,880 frames. Now, if my real-world situation, the thing that I'm recording, takes 90 days to play out, then 90 days divided by 2,880 requires a 4-minute and 30-second interval between frames. Finally, and probably I would say the biggest concern, at least if you're approaching time lapses from a cinematic perspective, is introducing some kind of camera motion. Now, the time lapse is certainly going to add interest to the shot just from the distortion that the time shifting creates. But adding camera motion takes things to a completely another level, hence the term hyperlapse. Now, the problem here is that you can't just say put your camera on a tripod and pan the head by hand and expect to get a good result. Even relatively short time lapses, we're still talking about recordings that are minutes or more long. And to get a smooth camera movement, you really need to move it in very small increments over that time and consistently. To do that, easily at least, you're going to need some specialized hardware. Now, fortunately, it's getting easier than ever to do this and add motion to your time-lapse recordings. Many action cameras and most smartphone camera apps have some form of computational hyperlapse capability. While they're not going to be quite as smooth as motion-controlled, computer-driven stuff, they can provide a great deal of frame-to-frame stabilization to make the time-lapse, or now hyperlapse, smooth and look good. However, the real boon for these hyperlapse shots is the availability of reasonably priced motion control hardware that has enough precision and capability to support the kind of small adjustments that are needed in this application. Many gimbals now that are on the market now have time-lapse modes, and they can drive the camera through a pre-programmed series of pans and tilts to point the camera in different directions automatically. Likewise, companies like Edelkrone make affordable motion-controlled sliders, heads, and jibs that can do the same thing for dolly and crane moves, and even dolly and crane moves with tracking motion. Now, while some certainly are not going to consider these tools cheap, after all, we are talking about things with price ranges from, say, $500 to $5,000, or maybe even a bit more. The reality is this is much cheaper than the 5- or 6-figure sums that you would have to spend to do this not that many years ago. So, where are we going with this series? Well, over the next several videos, we're going to explore this niche of photography in as much detail as I can possibly dive into. So we're going to look at the technical aspects of how to set up and shoot still sequences on Canon's mirrorless cameras and some of their DSLRs as well. We're going to do the same, but we're going to use the built-in time-lapse feature that is found on those same cameras, so you have both still sequences and videos out of cameras. Then we're going to jump over to Canon's cinema cameras and look at how to shoot time-lapses on them in video, which is incredibly powerful if you know what you're doing. Finally, once we get through all the basics of setting your cameras up to take a time-lapse, we're going to look at adding motion. And we're going to take a look at some motion control hardware, specifically a gimbal from DJI and the Edelkrone sliders. Finally, we're going to wrap all of this up by looking at post-processing and production techniques that you can use to, for starters, composite your image sequences into a video file, add motion blur to your videos if you need to, and we're going to do this post-processing on a range of software going from free open source tools so that you have no cost involvement at all the way up to some professional tools like DaVinci Resolve Studio. Now, with that said, I hope you found this useful, or at least interesting. If you did, let me know by hitting that like button and sharing this. If this kind of thing seems like it might be your kind of thing, please consider subscribing if you're not already. Finally, if you'd like to directly support this channel and future content like this, please consider hitting that thanks button if you can, or buying yourself something you've always wanted from one of the affiliate links in the video description. Either way, your support always is appreciated. And as always, thanks for watching, and I'll see you next time.